Today we're going to apply the concepts that we learned about on Friday in order to identify if something is an atom or an ion, whether or not it's positive or negatively charged, and ultimately where we need to go, how am I going to find out what something is and identify it. If you only have a symbol, how do you know if it is an atom or if it is an ion? Kelsey. Atoms are neutral, which means they are not going to have anything else in the symbol except for its element identity. That is an atom. Anytime you see a 2 positive, 3 positive, a number to the top right-hand side of that formula, that's telling you that it is an ion. Why does an ion have a positive or a negative charge next to it? Kelton?
It is missing protons or electrons.
Okay, so we're going to switch that around and talk about the electrons, because you can't change the number of protons of a substance, right? So if I'm talking about carbon, and I say, okay, carbon could theoretically gain 4 electrons, then become something that has 10 electrons and 6 protons. I wouldn't say that carbon has 4 less protons, because I haven't changed the number of protons, I've changed the number of electrons. So, an ion does not have the same number of electrons and protons. If it is a positive charge, do we have more or less electrons than protons if it has a positive charge? Okay, so in this case, we have less electrons than protons, and that is why the substance has a positive charge. If something has a negative charge, does it have more or less electrons? More. I think I'm missing this one. Mixing up my patterns. When you are identifying atom versus ion from the number of subatomic particles, you have to know what a proton is and what an electron is. Protons are positive. Both start with P, might be an easier way for you to remember. Electrons are negative. The atomic number on the periodic table, here it's on the right-hand side of my table, on yours it's on the left-hand side. This is the atomic number. It is also the number of protons. The modern periodic table is arranged by atomic number. The atomic number of a substance never changes. If it does, it's not that substance anymore. If I have an atom of carbon and I force it to take on one more proton, it is now nitrogen. You have to compare the number of protons and the number of electrons. And that will tell you if it is an atom or if it is an ion. Questions so far? Haven't lost anybody too terribly yet? Okay, I'll try harder. I'm kidding. I have a strange sense of humor when I don't sleep. In order to find out if something has a positive or a negative charge, you need to compare the number of protons and the number of electrons. If you have something with 20 positive charges and 18 negative charges, the substance is going to have a positive charge. 3 protons plus 2 electrons, that's positive. Here, there's more electrons. That automatically means it's a negative charge. Here, again, 10 electrons compared to 8 protons, that's going to be a negative charge. And finally, here we have a positive charge. The hardest part is the last question. You have to figure out what the element is first. You do that by looking at the number of protons, because the number of protons will tell you the atomic number. Once you have the atomic number, you can look it up on the table. Substance that has 23 protons is vanadium. Is this going to be an atom, or is it going to be an ion? It's going to be an atom. Good. We know that because the number of protons and electrons are the same. What's the difference between the first V and the second V? Why do you need a 5?
It's an ion.
It's an ion. And if we compare the number of positive and negative charges, positive 23 plus negative 18 gives us 5 positive. If we're representing the second substance, we must have the 5 positive beside its name. Otherwise, people don't know what you're dealing with. This substance, number 20, is calcium. Nothing to the top right-hand side because it has an equal number of protons and electrons. Next, we have the chloride ion, which is Cl1 negative. And finally, we have the boron ion, which is 2 positive. Oh, sorry, beryllium. Boron is next door. I want you to take 30-40 seconds and write down key points below that you need to memorize or know in order to be successful with questions like this. I want 3 people to share the key points that you've written down on the bottom of your sheet. Go for it.
Number of protons is the atomic number.
Okay, excellent. You need to know that. Absolutely. I need 2 other people to share.
I said if you're looking at the, what's it called? The atomic symbol, it'll be an atom if there isn't a charge beside it.
Correct. Third one. Third person to share a point that they wrote at the bottom.
Protons can't change.
You need to make sure that you understand why something is positive, why something is negative. Do you need to write a point about that? Okay. Please put those worksheets away and take your notes out of your binder, please. If you were away last day, your notebook is in your folder at the back of the room. As well, you may want to go on to Google Classroom and watch the video from Friday so that you can catch up on what you missed. So today's activity was just to warm up the brain cells and get you thinking about what we did last week. Last week we were talking about substances gaining or losing electrons in order to become ions. We have fancy names for gain and loss of electrons. If something gains electrons, we call it a reduction. If something loses electrons, we call it oxidation. And these come from reactions that we first documented, but we didn't actually know what was going on with the electrons at that point in time. So, for example, if you dig an ore of something out of the ground, you're going to have to reduce it so that you get just the metal that you want. versus oxidation was used to describe reactions like rusting. But we didn't really know about the electron part yet. We have two silly little sayings that we use to memorize the difference between oxidation and reduction. The first one is Leo says grr. Leo is the Latin name for a lion. The second silly little saying we have is oil rig. So loss of electrons is oxidation. Gain of electrons is reduction. Second one, oxidation is loss of electrons. Reduction is gain of electrons. And that helps us to remember the difference between the two. If you decide that you want to go on into Chemistry 30, we do a whole unit in this stuff. It takes about 3 or 4 weeks. So there are a few key points here. One of them most of you have already written down as one of your key points from the warm-up activity.
Oh, you were here. Oxidation loses reduction.
Hi, can I get the booklet that they got on Friday? Because I was on here.
It wasn't in your folder.
I didn't know I had a folder.
Okay, I'm gonna have to get you a copy of it.